This thing called hashing power. And where that comes from is, well, remember our hash function. H of m equals d, right? And m can be arbitrarily big, and d is small. You know, d is on the order of like 256 bits. Which means there are 2 to the power of 256 different possible digests, in theory. In practice, the math might not work that way, but we don't actually know. As far as we know, these digests are uniformly distributed, and every single digest is possible. And this is actually called the random oracle law. And so way in a proof, a math proof about crypto, you deal with the fact that nobody has a math proof for hash functions. You replace it with this magical construct called the random oracle. The random oracle is sitting up there in the sky. Other people might go worship it. Crypto people just go use it as a service. And you go pray to the oracle and say, dear oracle, I have message, hello world. Give me a digest for that message. And if the random oracle is doing this job, every possible message is assigned to a different randomly chosen digest. And presumably the oracle remembers which message goes where. Maybe it has a big database itself of all the prayers. But it will always return the same digest twice. But the key there is random. Right? All this works because for every m, d is completely random. If it's completely random, I can't predict in advance what message would give a certain property of d. Right? What if I want my d, it's 256 bits. What if I want the first bit to be 0? Right? I don't care about all other bits. They can be anything. But I want that first bit to be 0. How many messages I'm going to have to pick to go find that first bit being 0? Yeah. Because, I have to go try more than once. I might get lucky, but I'm going to have to try more than once. So, if we have 2 bits, now my odds go down even further. Right now, 1 out of 4 attempts is going to be successful. And I can make this, as unlikely as I want, right? And Bitcoin almost works this way, although it's a somewhat code, which is that what if I want something a little more granular? What if I want to go say that I want the probability of getting the right answer to be less than a certain amount, not just like, less than say half or a quarter, but less than an arbitrary amount. I want something that's a bit more granular. I don't want to just have the difficulty go jump, right, every time I go add another 0. I could actually say, let's make d, let's say this game is successful if d is less than the target value. And the target value is just some big number withheld a lot of zeros, right? But the zeros are followed by digits, right? Maybe it's a 1 there or something. And the less than means that I can be very granular on exactly how difficult it is. So the key with Bitcoin is that when you make blocks only be valid if their hashes are less than this target value. And since that's true, that means that finding a valid block means that we have to go iterate through a whole lot of different messages. Right? We got to keep guessing over and over again. And long story short is the way this works in Bitcoin is that that block header, right? For say block 10 or something. One of the things it contains in the fields is something called nonce. crypto, in crypto, a nonce kind of means a number used once. Technically, this usage of the word nonce isn't quite correct. This is more just a field you can arbitrarily change. And the way crypto mining works is where we take this field and we just keep, incrementing it until this condition is true. And for privacy, the way it should work is hypothetically at least, was you pick a random nonce to begin with and just keep incrementing. There's some tech details which mean that, for instance, the nonce field of Bitcoin is not big enough. It's 32 bits rather than something reasonably large. There's multiple nonces actually used, et cetera, et cetera. But the way it could have worked, if Satoshi had planned ahead a little more, was this would be a really big number, and you would just keep incrementing the nonce until you got lucky. And since target can be arbitrarily small, you can make it arbitrarily unlucky. The hardest difficulty you can imagine will be, what if we said that target was 0? Right? So Bitcoin block was only valid if less than or equal to 0, so h of n equal 0. Well, 2 to the 256 bits is a really big number. A good way to go put it is to go count from 0 to that, assuming you took, the most efficient possible computer that used the least amount physically possible of energy to increment one single bit every time. If you take the entire observable universe, convert it all into energy, and then run it through this huge orgy of computation, that's still not enough to count that high. So if the random oracle model holds, it is completely infeasible to run out of target, and in general, it's completely infeasible to break a hash function. Now our question is, though, how do we decide what target it is?
Based on the number of present miners,
Alright, so you're saying that we should adjust the target based on some amount of computing power, right? Well, how would we know how much computing power is being applied to Bitcoin?
based on time, 10 minutes. What do you just,
We can decide how often we want blocks to be found.
Alright, so our model is, we think there's a certain amount of miners, right? Or is that even true?
we don't know how many miners, we know how fast blocks can
Right, so we know what is, if I have, say, block, n, and block n plus 1, I can say that block n happened at time, 0, block n plus 1 happened at time 1, and the interval between them is just, the delta t minus t0, right? It seems simple enough. And somehow I will go use that to derive, the target. And you can imagine a whole bunch of different ways to do it. You might go say that, maybe you assume that there's a certain amount of hashing power and you divide it by t or something. Now, would that work?
Yeah, we can derive the hashing power of the network based on the target and the previous time the block, by which time the block was produced. So we can calculate the hashing power.
Alright, so that's an interesting question. So, in my function to decide the target, I have to base the output of that calculation based on an assumption about how hashing power maps to time, right? But nowhere in this do I actually know how often blocks are found for, given amount of time for given amount of hashing power, right? I don't know how many Bitcoin miners there might be, or how much hashing power they might have. calculation for the target has to be based on modifying an existing target. Right, I have an assumption about what the target is from the previous block, and if blocks are happening faster than I want, I have an algorithm that modifies the previous target in a certain way to make the target be less. So it's harder to find blocks than they happen slower. Or in the converse case, if blocks are happening slower than I want them to be, I make the target bigger. But the important thing is that algorithm, it always works on a previous target. Because that's sort of my connection to how many blocks per second per hashing power do I expect. This thing's important because what I'm trying to get at here is it is not a fixed calculation, right? It is a system that modifies the target. It doesn't know what the target should be exactly, but it can go try to adjust over time. If it's too fast, make it higher. If it's too low, make it lower. But at no point is there any connection to reality other than the fact that you can go back the whole way, all the way back to block 0, where there's an assumption. See, in block 0, there's an assumption that a target of a certain value is appropriate. And in Bitcoin, we have to call that difficulty 1. That term comes from exactly how this number gets turned into a target. Long story short is in Bitcoin, there's a certain assumption called difficulty 1, where difficulty 1 refers to a target that would require finding 2 to the 32 hashes, or trying 2 to 32 hashes on average for 10 minutes. And that assumption could be wildly inaccurate, but it's a starting point, right? You say that's the starting point, and then you go modify that over time. But hang on. When we said time here, how do you and I agree on the same time? Well, how is it constant? I mean, if I receive a block, like if I receive block 3B later than you receive block 3A, doesn't that mean we have different times? How are we going to calculate a target based on that?
Well, we both will calculate all the different targets.
Sounds like a problem, doesn't it?
Yeah. But first, we have to agree on the true state of the chain.
Well,
Yeah.
but we can't agree on the true state of the chain unless we can agree on what time it is. We've kind of got this problem.
Well, then the majority will agree, and that will be considered to be a truth. And the more I've exerted calculating that chain, the more truthful that chain will be.
So, alright, so you're going to say that, but I mean, why don't we just have a system where it's purely the most work attached to a chain? I mean, why bring time into this at all in that case?
Because we have to do transactions. Transactions have to be valid. I mean, valid transactions have to exist for the system to exist.
Alright, well maybe I'll put this a different way. I mean, in Bitcoin, it is true that we have a target, and the target is based on time. Knowing that, how do we determine what time it is to feed into this whole algorithm?
The minus, whatever type depends on minus.
Alright, but how exactly does my computer know what time was on the miner's machine?
We need to agree to synchronize our system against one particular feed. The question is what is one unique that everybody
Okay,
will look
so
at.
I like that. So we do agree on a certain time, but what would the actual mechanism for that be?
Is the transaction signed with that?
It exists today, when you run million
Alright.
systems.
That's interesting. That could be an interesting way to do it, but we'll say this: Bitcoin does not have transactions sign time. You probably come up with a system where it works that way, but Bitcoin doesn't do that. There's another place you put it.
That can be a block thing.
All right, so you're saying that blocks could have the time field, which would then mean that every time I talk about time, I'm not actually referring to wall clock time. I'm referring to what the block claimed its time was.
It's easy to manipulate.
Well, it's an interesting question. Is it easy to manipulate? But let's just go back to, let's say, all right, so the time block n happened. We say that's time block n. And time block n is actually just a field in the block header. All right? And again, it's just another field in this block header. N plus 1. And if miners put the time in their blocks, then we can run all the calculations for what difficulty should be based on that number, which should be the valid, should be the actual time. And because we're all agreeing on the same number, we can come to the same conclusion, right? Because after all, this is a rule. Like, if you and I come to a different conclusion about what the target is, bad stuff happens. You and I might have different blocks. So getting this part right is really important. Right? Let's ask, suppose that my answer for the target was one bit different than yours. Literally like a 0 is a 1. Well, that could mean that if a block is exactly on that threshold, I might accept it as valid while you reject it. And now we don't agree on what the blockchain is. So getting that right is very important. But the question here is, well, since miners are self-reporting, what could they do with that field?
You could artificially make the difficulty easier or harder based on when they release blocks and what time they put in the block.
Right, so I'm a miner. Let's suppose I want to make more blocks than I'm supposed to per unit of time. Alright? Because after all, I get some benefit to creating a block. We haven't even touched on that part yet, but I get a benefit for creating a block. So now I want more of that benefit. What would I do to the time field?
You also put it in the past.
Alright, but if it's in the past, then that means blocks are happening faster than they should have.
So you put the future.
Yeah. Well, what stops them from putting it way into the future?
Difficulty would get harder for them.
Well, if it's way in the future, difficulty becomes easier, right? Because blocks are happening too slow.
They will not be able to calculate that message in time.
But time is just a number, right?
Someone else keep it.
Well, others will reject that block because you have to propagate the block to the other miners, to the other nodes. And but if they have the target in mind, and based on that target, they can calculate the message hash it and see that there's not enough zeros.
But remember, that target is based on the time field of the block itself, right? That's a self-reported time. So what stops me, the miner, from claiming, well, my block was created now, and now happens to be 2019. You might think it's 2018, but your clock's just wrong.
If someone said they found a block in 2018, they would cut off their block? Or because it hasn't reached it?
Well, alright, so your computer is receiving my block. I'm telling you in the block header that right now is January 1st, 2019. Why would your computer reject that block? But if it doesn't reject it, then what stops me from making the difficulty lower than it should?
So I think we only calculate
Is there another threshold to the difficulty?
Hmm?
Is
set a upper threshold for the difficulty so that it doesn't go beyond 10 minutes to the states.
Well, if there was an ultimate upper threshold to difficulty, I mean, what would happen to Bitcoin if a huge amount of hashing power existed? Like maybe so much hashing power that you could go brute force like 64-bit hash collision, you know, every 10 minutes. I mean, that would be completely unthinkable 5 years ago. Now that's the state of Bitcoin. And it astonishes cryptographers every day. You know, like you can't put up a limit to hashing power. So somewhere in this, you have to go put a limit. And I can tell you, the actual limit is that your node says, all right, I have wall clock time. If I receive a block that claims to come for more than 2 hours into the future, I'm going to reject it. Which is interesting because in the future I would have accepted it. But now I will reject it. So that's actually the one part of Bitcoin out of all this where we have a rule that's based on something that could be different between two computers. Right? If your clock is a little different than my clock, I'll reject a block that you would accept, and vice versa. And if this feels a little ugly to you, well, it feels ugly to me too. I mean, not many people have studied this in great detail, but I suspect that's a major problem for Bitcoin if miners really try to screw with you.
Yeah, certain number of miners agree and accept the block to the computer share.
Well,
It's the 51% of that they can do.
yeah, I mean, there's just all kinds of messes. But, I mean, maybe there's one thing though that could make this less bad than it was. Like, remember when we talked about, you know, what are the rules for picking which of these two blocks? Well, let's go and just draw a cleaner version of this. Alright, so again, we start with block 0, right? And you have a whole bunch of blocks, and then the blockchain forks. So I would say that right here, we're at block 0, 1, 2, 3, 4, 5, 6, 7. All right, so that is block 7. If that was 7, 6, 5, 6, 7, 8, 9. So that's block 9. Well, which block should we pick? I mean, there's going to be a rule. We're going to make the assumption that you and I know about all these blocks. We know they all exist. And of all those blocks, we have to decide which of them is the valid chain.
The longest one, I would assume.
All right? It's the longest one.
Why longest one?
Just because it's the longest.
But how do you know it's gonna stay the longest?
Well, what if everyone picks the
At
longest
same
chain?
time.
Yeah, well, if
It's
everyone,
time different.
everyone agrees on the longest block is the longest.
Well, more importantly, if we make the assumption that because in the rules, the longest chain is valid,
Yeah.
people should go keep building on the longest chain. Obviously, we should pick the longest chain. And you might have also read the Satoshi white paper, where he goes and says longest chain over and over again. And you might have downloaded the Bitcoin version 0 source code, where the rules are the longest chain. Now, can you see a downside to this?
If the longer chain is made with less work.
Right. So because we can adjust difficulty, you could wind up in a situation where, you know, it might take a little longer than this. I mean, the nuances of it are that difficulty doesn't adjust immediately. It takes time. But long story short is, you could be in a situation where this chain was longer, but less work had gone into it. And this chain was shorter, but more work had done. And that would have happened because at this point, the difficulty would be down. All right, so we'll say difficulty for block E9. If that is less than this, less energy was used, less attempts were used to create this. And a really good example is actually Bitcoin testnet, right? Because if I'm going to develop a Bitcoin application, I don't want to test it with real Bitcoins. So you have this complete parallel network called Bitcoin testnet. And Bitcoin testnet is far more blocks than Bitcoin mainnet. Now, there's a few reasons why, but if the rule was purely length, you would choose Bitcoin testnet. Aside from the fact that B0 is fixed, and Bitcoin testnet is different. Ignore that part. But other than that detail, you can conceivably choose Bitcoin testnet. So in fact, like you say, the real world is most work. And interestingly, Satoshi did actually get this wrong. The first version of Bitcoin was longest chain. And that was actually changed. I think it would have been version, don't quote me on this, but I think it was like version 0.2. And that was, it wasn't advertised to change, but if you look in the details, there's a git commit for some change to the RPC interface, which is, some boring things that you write Bitcoin services with. And in that innocuous looking change, you completely rewrote it to make it longest change rather than most work.
I mean, the other way around. Most work rather than longest chain.
Yeah, so it was originally the longest change was changed to be most work. And any sane blockchain works that way these days. And since it's most work, that does defeat some of these timing things a bit. In that, like remember we were talking about how the threshold is derived from the time. At least because most work chain wins, it's not like you can just say, well, my blocks were created in the future and I created a whole bunch of them and, difficulty was low. That actually is a little bit irrelevant from that point of view. The attack, that particular type of attack doesn't work in general because with a little bit of hashing power, even if your blocks were valid and they looked valid because you screwed with the timestamps, that still gets beat out by the real chain with more total. And there's a lot more complexity to that under the hood, but that statement's roughly right. So now after all that, do we have a system that works? Right, because we can agree on what transactions, we can agree on what coins are real, we can use crypto to make sure only the right people can move the coins, and we can come to consensus on what chain to use. So we're done, right? All right, what's missing?
I just knew that's where you were going.
I'm kind of predictable that way. Although I better, after we're done, I better go and I'll do the same thing. Actually, if I fully explained Bitcoin in every single possible way, I could still ask that question. And there's still big things to go change that don't exist in Bitcoin, but there is something missing in my description.
Minor centralization or decentralization.
Right. So why am I doing all this work again? Right, I get paid. And see, the reason why I left this for last is because if miners were doing this work for some other reason, maybe out of the goodness of their hearts, in theory Bitcoin would work. Right? All this technical stuff would still work as described. You can still come to consensus. The only difference would be, well, I mean, how much work would have actually been done? I mean, how many dollars would have been spent on Bitcoin as electricity? I don't know, maybe a few million, if people are feeling really generous. Well, if it's a few $1 million, then I can create an even more work chain that reassigns everyone's money to everything else and screws with everything, right? But in Bitcoin, miners are incentivized with two mechanisms. First of all, every block is allowed to create money out of thin air. So remember our rules here? Like, we have the list of, more money comes in the input than output, et cetera, and the last one was coins are real. Well, every block is allowed to contain a transaction, TX0, which is called a genesis transaction. And the genesis transaction has a special rule that applies to it, which says it is allowed to spend a coin that doesn't actually exist, the Genesis output. And the Genesis output is treated as though it has a certain value. And that value is assumed to exist even though it doesn't. And since it doesn't actually exist, you've created a certain amount of money out of thin air with every block. Alright? And that money you've created, well, you can spend it like any other money. Thus, if you're a miner, you get free money for every block. Well, free. The other thing is that, like, remember our rule here where, you know, funds in less than or equal to out. What Bitcoin actually does is, while this is true, it takes all that difference and all the different transactions, other than the Genesis one, and adds it all. We call that the fee. Right? And that's a sum of the difference between input and output of every transaction. And that money would have otherwise been destroyed, right? Because it wasn't assigned to an output. But instead of destroying it, we have added to the value of the Genesis output. Thus, miners are allowed to, you know, not only create money out of thin air, but also collect money that other people would have destroyed, you know, in that particular way. And that also means that now I can give miners an incentive to include my transaction. So otherwise, I mean, how would miners pick between every transaction? Why should they mine my transaction versus yours? Well, because my one paid more money. An interesting homework assignment would be double check that this calculation actually worked. Because I'd really hope that the fee wouldn't include transaction 0. Right? Because suppose it did. You could imagine someone making a mistake where the fee included the first transaction, and thus you could go and create money out of thin air that way recursively. I'm pretty sure Bitcoin didn't screw up that way, but it would be an interesting thing to double check. But yeah, getting back to it, now we have an incentive, now we have a reason for people to create blocks. And, you know, we now that we have that reason, it should be quite expensive for this guy to make this attack by creating more blocks. And you could get into the monetary arguments of it, but long story short is right now, Bitcoin is quite inflationary. People often tell you it's deflationary, but you know, currently, like the total coin supply, I think the numbers are like 5% per year is getting created out of thin air. And that 5% is free money that miners can go spend on security. You know, that 5% is essentially the money that miners get for free to go secure the coin. In the future, the way Bitcoin works is this subsidy gets halved every 4 years and will go to 0. And I'd be lying if I said I thought that was a good idea. I mean, frankly, if I were Satoshi, I would have designed it that there was a fixed inflation rate constantly. But, you know, that gets into a whole other topic. Right now, at least, we can say Bitcoin certainly works because the amount of money miners get is quite big. And there's a whole lot of discussion you had about that.
Sorry, when you say fixed inflation rate, you mean it would stay at a certain percentage every year and there's no limit on the maximum amount of coins?
Yeah, that's exactly what I would do. To get down to the nitty gritty, the way I would have designed it would have said, all right, the money field is, you know, 64 bits. Let's work out at that fixed inflation rate how many coins will exist in say 1,000 years, and just make sure that that number is less than 2 to the 64.
And the rationale of that would be to
Basically,
stay in
the
line.
software will probably work without modification until I'm very, very dead. Like as an example, that time field I mentioned, well, that time field overflows around, I think it's 2137 if I remember correctly. So depending on how long I live, I might be around long enough for Bitcoin to fail technically because that number overflows.
What's the due date? 64?
Yeah, it's 64-bit seconds since 1970, and it will overflow pretty soon too by normal standards. You know, and again, I mean, there's fields in Bitcoin that refer to the number of blocks. Well, the number of blocks will overflow those fields 4,000 years in the future. You know, everything eventually fails due So if I were to design Bitcoin, I would have just picked an inflation rate that would create an amount of coins that would overflow the field, say 1,000 years in the future, and call it a day. And I just picked the inflation rate low enough that it probably wouldn't matter. I mean, if you can't afford to spend, say, 0.1% on inflation every year, I mean, what are you doing with your money? Why aren't you rich enough to afford a 0.1% security tax? We afford 5% just fine, so, but, that's a whole nother issue. But I'm still missing one thing, which is, all right, if you get a reward for every transaction, because they pay fees, well, what if there's a lot of transactions? I mean, why shouldn't I accept every transaction that I see into my block? I mean, what if 10 million people want to do a transaction in the next 10 minutes?
Block size.
Right, so we put a limit on it. Well, how do we pick that limit?
Yes, Satoshi did.
Yeah, in Bitcoin it's just fixed.
Pick a number that makes the block propagation within 10 minutes.
Well, if I wanted to really explain this fully, I think we'd be here for another 2 hours. And I'd rather give you some time for questions. But long story short, that's, like I was saying earlier, that's the thing that gets very complex and is kind of unfinished. And in Bitcoin, the answer is you just put a limit on it. It's hard-coded. And that's just creates a market mechanism. Essentially, you have that much supply block space, a certain amount of demand, fees are a supply and demand thing. And if fees go too high, well, I think there's some gesture I do here with one of these fingers. And that's kind of our answer for that. And quite frankly, I don't think anyone has good answers to this, other than fix it and hope it all works. Because if you didn't put a limit on this, well, what would I do as a miner? Well, I'm a miner. I don't want you to be a miner too. You're in competition. So I'm going to accept as much crap into my block as possible so that you're going to get it not very quickly. Because you only start making money once you get my block. Right? The longer it takes you to get that block, the more money I make relative to you, and thus the next iteration of this, I will make yet more money. All right? It's an easy way to put your competitors out of business. So, long story short is that's the ultimate rationale for that limit, which is give everyone an opportunity to validate everything fully. Similarly, if you're a user of Bitcoin, if you haven't checked that whole blockchain, how do you know that money I used to go buy my house actually existed? What if I created it out of thin air?
Would a disincentive to that be lowering block propagation times?
Well, remember, as a miner, over a certain amount of hashing power, I want block propagation to be higher, not lower.
Yeah, but that would mean you want to lower the number of transactions so that it's propagated faster.
Only if. Essentially, the way the numbers work is that is only true if I, in my buddies who work with me, have less than 30% of the hashing power. And the way it works in the limit is that, well, let's suppose 90% of miners will get it within a certain amount of time, but the other 10% won't. That 10% essentially get pushed out of business. Well, now they're no longer in business. Thus, the process repeats again. And you can just keep shedding miners over and over again until finally there's a very small number. But I think we have a few more minutes for questions. See what you have to ask.
Sure, the Lightning Network everyone talks about several implementations, and obviously, like it's a second layer solution. In your view, will it really solve the block size issue and will it increase the adoption?
I mean, it certainly makes things better, but like when you use the word solve, like if I'm going to use the word solve, I want solve to mean I can have an unlimited number of transactions. And they can be from anyone to anyone with no restrictions whatsoever. Lightning definitely doesn't solve that problem. But then again, nothing does. There isn't tech on the planet that could make this number be infinity. Lightning solves it better than essentially anything else I've heard that's, you can deploy now. I mean, it solves it in the sense that with Lightning, I really could send you a penny, and it really would work. And I can send you that same penny, a million times over. I mean, Lightning's proven by Satoshi Dice, where literally you're doing microtransactions to paint pixels on a big display. No other service in the world can offer transactions cheap enough to make Satoshi Place possible. PayPal can't do it, Visa can't do it, nothing can do it other than Lightning. But Lightning does have the problem that every channel, every participant in Lightning did make at least one transaction. So at some point, this number of transactions still gets overflowed.
Yeah, you have to open it and then eventually have to close it.
Yeah. Another thing with Lightning is, like, because it's based on punishment, well, punishment can only happen by broadcasting a transaction. You can imagine not being able to broadcast a transaction because there's too many transactions, or because miners are censoring me, or who the hell knows. Under those circumstances, Lightning fails really, really badly. And that's probably not likely, but it's a different security model than Bitcoin. And we should recognize that's true. The thing is, ultimately, though, what's the alternative? We just don't have alternatives.
What about all the new networks that come up and promise, I don't know, 100,000 transactions a second?
Yeah, I'd say most of that's just blatant lies. Like, people often advertise these things 100,000 transactions per second. Well, where did they get that number? Well, they ran 3 nodes in a data center with gigabit Ethernet links to each other, and it didn't quite fall over. That's just not a decentralized system. That's the sort of marketing you give to people at Visa to say, hey, you want a better data center? We can get you a better data center. But it's not a decentralized coin. Equally, when people complain about Bitcoin can only do, n number of transactions per second, where it's usually 7. Actual number right now is probably 14-ish, but depending on how you define it. But it's small, but what Bitcoin does is completely different, because Bitcoin doesn't have a guy in control. And that just makes everything harder. I'd also make the point that, as a guy who also does sort of blockchain stuff for banks and whatnot, the idea that doing 100,000 transactions per second is hard is dumb, because that's making assumptions about what architecture you have that you didn't need to do. I can easily come up with tech that'll do 100 million transactions per second. This is not a hard problem. You take your database, you split it into different shards. This is solved tech. The only reason there even is a number is because you're using a database that can only run on one computer. If you're using a scalable database, you can run on as many computers as you want. You can do as many transactions per second as you want. You don't hear Gmail saying, well, the upper limit for the number of emails Google can send and receive per second is, 1 million. That's just not true. Gmail can scale as big as they want. There's a certain cost per user, but their architecture scales so that that cost stays the same no matter how many users they have. All right, admittedly at some point it'll go up, but that's because we've got an entire human race and the goal of creating computers to run Gmail. But everything has some scaling problem eventually. From a computer science point of view, they don't have a scaling problem.
So I have a question for you. If you see Bitcoin as an immutable series of Merkle trees, do you see any other purpose for it other than exchanging value?
There's a lot of things you do with a mutable series of Merkle trees. In fact, most of my work is really exploiting those other things. Not much of that work is actually being made into production, but a whole lot of theoretical stuff at least. Like as an example, well, because a transaction output can only be spent once, you can make a transaction output represent something else. All right? I can make that transaction output represent the ownership of my house. And when I spend it, I can make in my ownership protocol that mean I'm transferring the house to someone else. Now, being a house, the idea of what ownership means ultimately will come back to some group with a bunch of guns. But using a mechanism like that, you can at least audit that group with a bunch of guns, respect to the decisions of who actually owned the houses.
Isn't that the reasoning behind the development of Ethereum and these other
Yeah,
altcoins.
And I would say that essentially the reasoning behind the development of Ethereum, I think Ethereum is going about it the wrong way. I think the architecture they've chosen for that doesn't make much sense.
It could have been done on Bitcoin.
Basically, and had it been done in Bitcoin, it would be a lot simpler and a lot more likely to work. But notably, when I gave my example of tying ownership house to transaction output, when that transaction output changes, there's no Bitcoin being used directly. In fact, I could tie ownership of 1 million houses to one Bitcoin transaction output. And me being the land titles office, well, I could say, well, whenever I move it, I'm changing ownership for all sales that happened in, say, the past day. Now I'm, creating an immutable log based on an immutable log, and being a centralized housing agency, that's totally okay, because I'm proving my honesty. I'm not making it possible to sell a house without my involvement. That's impossible. Ownership is a legal concept. But I am auditing.
So last follow-up to that. What's the benefit of doing that